So the ones that you're sorry, the ones that you're able to do by hand are the special angles. The special angles in degrees are 30, 45, 60, and the quadrantal angles 0, 90, 180, 270, 360. In radian, this corresponds to the over 3s and the 6s and the 4s, and the quadrantal angles, so 0, pi over 2, pi, 3 pi over 2. Anything else is not a special angle, and you can't do it by hand. Therefore, you will not be given any of those, okay? So we're going to do this in reference to the unit circle. So the first one here that we're going to do is 7 pi over 6. All right. You're going to visualize this. So 7 pi over 6, what I do is I say in improper fraction, 7 pi over 6 is 7 over 6 pi. In mixed number, this is 1 and 1 over 6 pi. Okay? That means if I go on the unit circle, I go a full pi, that's the 1, and then I'm going to go another 1/6 pi, which is just past that axis there. So I'm there. Now, pi over 6, 1 over 6 pi is a very small angle. So that's like your 30-degree angle. So you visualize this triangle, and because here you have a small angle, that means it faces the small side. Okay? So the opposite leg, the vertical leg, is the small one. In a 30, 60, 90 triangle, the legs are 1 over 2 and root 3 over 2. So since it faces the short one, it's 1 over 2. The vertical is 1 over 2. We're looking for sine, right? Which is the vertical one, so it's 1 over 2. Now, as far as positive or negative, in the third quadrant, tangent is positive, sine is negative, so I put a negative in front. That's all. That really is all. And we can do it without that fancy unit circle. We can do it with a unit circle that we create. Okay? So basically, look at this one. Cosine of... It's in the third quadrant. In the third quadrant, all students take tangent is positive, sine is negative. Okay? Now look at this one. 5 pi over 4. This is 5 over 4 pi, which is 1 1/4 pi. Okay? So look. That means I go a full pi and then 1/4 of a pi. Okay? That's like my 45-degree triangle, right? In this case, the two legs are of equal size. Root 2 over 2, root 2 over 2. Now it just so happens cosine is the horizontal side, which has a size of root 2 over 2. So here, this is going to be root 2 over 2. Now, is it positive or negative? In this quadrant 3, cosine is negative, so it's negative. Okay? Yes?
How do you know like
1/4 is half one of the square, or like one of the corners, right? So look, you have, this is a full quadrant, right? 1/4 is exactly in the middle of that. So for example, if I go from here to here, that's half a pi, right? From here to, okay, if I go here, that's a full pi. Now I have to go 1 more quarter. If this whole thing is half a pi, 1/4 is half of it.
But then like what about like 1/6?
1/6 is a very tiny sliver. So 1/6 is right there. That's 1/6. If you have to go 1/6, you go just past the axis. Okay? All right, so look at this one. This is an over 6. Here we have 11 pi over 6. 11 over 6 pi is 1 and 5 over 6 pi. Okay, so let's see where that takes us. All right, look. Here is 1 full pi, right? Now I have to go 5 over 6 pi. 5 over 6, that's almost another pi, right? So I'm going to go almost all the way around, stop short 1 over 6. Okay? Now, what do I have here? The vertical side is that the shorter or the longer one? The shorter one, so it's a half. The horizontal side is the longer one, root 3 over 2. Hypotenuse is always 1, unit circle. Now, for the tangent, I have y over x. So it's the vertical over the horizontal. Okay? The vertical side is a half. The horizontal side is root 3 over 2. Vertical over horizontal, because the formula for tangent is y over x. Okay? Now, the denominators are the same, so they magically go away. So what I have left is 1 over root 3 over 3. Now, in the fourth quadrant, is tangent positive or negative? Negative. So this is negative root 3 over 3. Okay, and we just did 3 problems with radian, with no calculator, all mentally, and look, we're all still alive, okay? We survived it, so it can be done, all right? Now, the next one is secant of 270. So let's see where 270 is. 270, this is 180, 270 is right there. It's on this axis, right? So if I go to this point, what's the coordinate there at that point? X is 0, y is minus 1. Okay, this is how we do quadrantal angles. X is 0, y is minus 1. Now, secant is what? Hypotenuse over adjacent, or it's r over x. R over x. Okay? So this is going to be the radius, which is 1, over x, which is 0, and that's undefined. If you write 1 over 0 and you don't write undefined, I cannot give you full credit, because you need to know that that's undefined, and you need to tell me that you know that it's undefined. Yes? Okay, so this is, now the reference angle is pi over 6, which is like your 30 degree. That means the legs of the triangle are either 1/2 or root 3 over 2. Okay? Right, but remember we divided everything by 2. It was 1, root 3, and 2, but we said this had to be 1. So we divided everything by 2 for the unit circle. Okay? So now this is 1, this is 1/2, this is root 3 over 2. Okay? We can go over it a little bit more afterwards. Okay, so let's do a little bit more here. Cosine of 9 over 4 pi. 9 over 4 is 1/5 over 4 pi. Okay? That means, I'm sorry. Sorry, that's 2 and 1 over 4. Okay, so here we are. All right, I go a full 2 pi. Now I have to go another quarter pi. The quarter pi is halfway in one of my quarter slices, right? So right there. Now, if I'm at pi over 4, that means both legs of the triangle have equal length. Root 2 over 2, root 2 over 2. Is cosine the horizontal or the vertical, by the way? Not that it matters. Cosine is horizontal, root 2 over 2. So this is root 2 over 2. Is it positive or negative? Positive. Okay? Sine of negative 300 now. Negative 300 means I'm going to go this way, but stop here. Okay? So how big is that angle? The reference angle? 60. Now, does that mean, okay, so now I have a vertical and a horizontal side. Which one is bigger? The vertical is bigger because it's a 60 degree, right? The vertical is root 3 over 2. The horizontal is a half. Now, is sine asking for vertical or horizontal? Vertical. So this is root 3 over 2. Positive or negative? Positive. Why? Right. 29 pi over 6. Angle going to be? Pi over 6. Huh? For 29 pi over 6, the reference angle is pi over 6. So now let's see though. Whenever it's over 3, the reference angle is pi over 3. Whenever it's over 6, pi over 6. Whenever it's over 4, pi over 4. There are no other. Okay? So what's 29 over 6 in mixed number? 4 and 5/6. Right? Because 4 gives you 24, and then you have 5 over 6 pi. So we go 2 pi, 4 pi, and I have to go 5 over 6 pi. This is just short of a pi. That means I go here. Okay, that's 5 over 6 pi. So now it looks like this. Okay, now is the horizontal going to be the longer leg or the vertical? Which the horizontal is the longer leg. So it's root 3 over 2 and 1 over 2 for the vertical. Tangent is vertical over horizontal. 1 over 2, root 3 over 2. The denominators cancel. So it's 1 over root 3 over 3. Positive or negative? Negative. Okay? Now, how do we become experts at this? There you go. Do Monday. Okay, so plus 4.4.
That's a good try.
Wait, this and 4.4?
All right.
There's no point having a break, so the teacher's just going to give us too much homework.
Can I take some math?
Oh, great.
Use the rest of 4 minutes.
Well, you know, like teachers are sending the final projects and stuff.
It's actually easier to graph without.
Are we allowed?
Nope. Welcome to pre-calc. What are we dividing though? I know it's such an inconvenience going to school. All right, so let's talk about sine and cosine. So sine and cosine are waves. Okay. Here's an example of how sine of x looks, and here's an example of how cosine of x looks. Okay. So the domain for both sine and cosine is all real numbers. You need to know that. Okay. What you also need to know is that both sine and cosine oscillate between 1 and -1. Okay? That means, not typically, always, sine and cosine oscillate between 1 and -1. Their range, it's set in stone, is -1 to 1. Okay? That means you can't go above 1 and you can't go below 1. Okay? Below -1. So if you take a look at this this graph here, all right? Look at where the sine of x starts. It goes up, back down, back up to 0, and after that the cycle starts all over again and again and again, infinitely on both ends. Okay? So this part of it, this much of it, is called one cycle of the sine. Okay, this is one cycle. Now, how far have we gone on the x-axis in order to complete one cycle? We started at 0, ended at 2 pi. That means we went a distance of 2 pi on the x-axis before completing a cycle. That also means that the period of the sine is 2 pi. All that means is you have to go a distance of 2 pi in order to complete one cycle. Make sense? Now, let's look at a cycle of the cosine. Cosine starts here. So this is the main difference between sine and cosine. Sine starts at 0, cosine starts at 1. Goes back down and back up. Here, that's one cycle. How far did we go along the x-axis to complete one cycle? 2 pi. So the period of the cosine is also 2 pi. Okay? That's always true. So the three things you have to remember right now are domain is all real numbers, range is -1 to 1, and that applies to both, and the period is 2 pi. Okay? That means that's how long it takes for them to complete one cycle. All right. This is how the equations look for sine and cosine. All right? Now, let's talk about one more thing, amplitude. Amplitude is how high the wave goes. The default amplitude is 1. So basically, if you go to the wave, this is the wave, if you cut it down the middle, vertically, now this vertical distance from the middle to the peak and this vertical distance from the middle to the valley are both the same, and they happen to be 1. So for the default sine and cosine, the amplitude is 1. In the equation, what tells you the amplitude? It's this number A. Okay, the absolute value of A tells you the amplitude. Okay? Now, we're going to graph one. All right, so here it says, describe how the graphs of the following functions are related. Then find the amplitude of g of x, sketch 2 periods of both functions on the same coordinate axes. Here we have sine of x, here we have 3 sine of x. What's changed? The 1 to 3. That means, whereas here, the amplitude is 1, here, the amplitude is 3. Okay, so the amplitude for g of x is 3. We're going to graph both. We're going to graph both. So, okay, so first I'm going to graph sine of x. Later. First I'm going to graph sine of x. Okay? So sine we know starts at 0, goes to 1, then 0, -1, 0, okay? The period of the sine is how big? 2 pi. Okay, so we're going to go from 0 to 2 pi. All right, so sine starts at 0, goes to 1, goes to 0, -1, and 0. So if you remember where to start it, then you can do the rest, okay? And here is how it looks, okay? Now, if you look at this closer, you'll see that it has how many divisions? 1, 2, 3, 4, right? Those are the 4 critical divisions, all right? And it oscillates between 0, 1, and -1, always, for sine and cosine. Okay, so if we want to draw a second period, right, because it says sketch 2 periods, most of the time I'm just going to ask you to draw 1 period, but for the beginning, let's do 2. You do the same thing. You start at 0, you go 1, 0, -1, 0. Okay? What did I do? Sorry, hang on. This is still for the sine. Okay? We go to 4 pi. So this is f of x equals sine of x. Now we're going to graph g of x. No, you stop it at 4 pi. Absolutely, you stop it at 4 pi. Okay? Huh? It's not a sharp edge. It's a curve. It's continuous. It's a curve. Okay. So g of x has an amplitude of 3. That means instead of 1 being the highest point, it's now 3. The zeros stay where they are. The maxima and minima will change. So we go from 0 to 3 to 0 to -3 to 0. So it looks like this. Okay? Oh, 3. So past the 0. Okay? And if we wanted to do another one, then it's the same. From 0 we go to 3, then back to 0, then -3, then 0. All right, so you I did the best I could here, but this shouldn't be a sharp edge here, okay? All right? Any questions? So most of the time, I'm just going to ask you to graph one cycle. That means you would end at the 4 pi, at the 2 pi, okay? All right, so here's another one. In this case, look at what we have here. We have a negative out front. What does the negative do? The negative is a reflection around the x-axis. And what does the 2 do to the graph? Amplitude changed from what? 1 to 2. Okay, so the amplitude of g of x is 2. Not -2, but 2. Amplitude is always in absolute values. Okay? All right, so let's graph cosine of x, f of x first. The period of the cosine is 2 pi. Okay, so it's going to go from 0 to 2 pi. Where does it start? Does it start at 0 or 1 for the cosine? For the cosine, I'm graphing f of x. It's just straight cosine. Starts at 1. Okay, once you know the starting point, you're now just going to oscillate between the 3 values, 1, 0, -1. So from here, you can only go to 0. Then you go to -1 because you haven't hit that yet. Then back to 0 and back to 1. So that is one period of the cosine. And if you wanted to do another period, then you go to 0, -1, 0, 1. That's what it looks like. Okay? Now, for g of x, we're starting at what point instead of 1? Negative 2. So we start here, go to 0, up to 2, 0, down to 2. And then we do the same thing. The negative, well, you see how we started at 1 here on the positive side? Here we're starting in the negative side.
But you started with negative. Oh, okay.
Yeah? Okay. All right? So that's how you do that. Okay. Now, how do you figure out what the period of the function is from the equation? So here's what the equation looks like, right? You have an A, you have a B, right? The period is 2 pi over B, absolute value of B. Okay? That's how you figure out what the period of a function is. Now, when the period is modified, the best way to graph it is this. You take bx plus c and you solve this inequality. Okay? So look at this one. The graph is cosine of x. All right? Let me very quickly graph cosine of x because we're experts at it right now, right? So what does cosine of it, where is it going to start? 0 or 1? 1. And it goes here and here and here and here. Okay? All right, so when you have the half, that means the period has changed. Okay, what's the amplitude of this g of x? 1. Okay, so to figure out the period, you do 2 pi over b, which is 2 pi over the b is 1 over 2. Okay? Which is how much? 4 pi. Because it's 2 times 2, 4 pi. So that's the new period. So instead of completing the cycle in 2 pi, it's now going to complete it over 4 pi. It's a slow wave, okay? And that makes the difference between your X-rays and your radio waves. Okay, it's just a difference of how slow and fast the wave is. Okay. So that means we're going to start here and go to 4 pi. So what you want to do always is this. Take the bx term, okay, and set up this equation, inequality. 0 less than or equal to half x less than or equal to 2 pi. Okay, 0 to 2 pi, because that's what the period is. Now I need to isolate the x, so I multiply by 2, I multiply by 2, I multiply by 2. This goes away. So what I have is 0, x, 4 pi. In this example, it's sort of like, it's a basic example, so we already knew that I was going to go to 0 to 4 pi, but afterwards this will come in so handy. So we're going from 0 to 4 pi. What's the halfway point between 0 and 4 pi? 2 pi. Remember, we always want 4 partitions. So now we have 2. What's the halfway point between 0 and 2 pi? Pi. What's the halfway point between these two? 3 pi. Okay? Now, we're starting at 1, right? We go to 0, negative 1, 0, positive 1. Okay? So here's what this looks like. You see that? It's a much longer wave, twice as long. All right? So that's how we graph. Is this becoming, are you guys seeing the point here? Okay. So, frequency is how fast a wave is. So basically, if there was a wave passing by like under the table here, and if you were like lying down on top of the table and you had a stopwatch and you say, okay, I'm going to count how many peaks pass by in a minute, that's the frequency of a wave. That's how fast the wave is. So frequency, and what was the formula for the period? 2 pi over b. This is b over 2 pi, meaning 1 over period. Okay? So does anybody play the tuba? Somebody in my other class said they played the tuba. I guess so. How many more, how many different people could there be who play the tuba and that go to this school? So a bass tuba can hit a note with a frequency of 50 cycles per second. Hertz is the unit. And an amplitude of 0.75. Write an equation for a cosine function that can be used to model the initial behavior of the sound wave. Okay, so let's just write down what we have. We have the frequency, which is 50, right? What's the formula for frequency? B over 2 pi. So B over 2 pi is 50. That means how much is B? 100 pi, right? And we're also given amplitude, 0.75. What's the formula for the cosine wave? A cosine bx plus c plus d. All right? We're not given any information for c and d, so just knock it out of the equation. What we have left is y equals a, which is the amplitude of 0.75, cosine 100 pi x. That's it. That's it. Well, b over 2 pi is 50, and we just solved for b. Huh? 2 pi over b is the period. B over 2 pi is the frequency. They're, so if you know how like these fluorescent light bulbs, sometimes when they go bad, they hum? You know, like, right? That's the frequency, and okay, so because we all in the United States run on the same voltage, how much voltage comes out of here? How many volts? 120 volts, right? You've seen that on like your adapters. Anywhere in the US, we use 120 volts. So no matter where you are in the US, if you have a light bulb, fluorescent bulb that's going bad, they hum at the same note, at the same frequency. It's the same hertz. The frequency of the short wave is higher, meaning the period is shorter. That's it. Yes. AM radio waves are very long waves. Okay, so phase shift. Remember how back in the day we used to graph things and they had a horizontal translation where you moved it like right 3, left 3? When you're graphing sine and cosine, just to make things fun, we don't call it a horizontal translation. We call it a phase shift. Okay? So you save a few syllables, but that's all it is. It's just a horizontal shift. Okay? Here's how we find phase shift. Basically what you do is you take bx plus c and set it equal to 0. That's it. And you solve for b. Solve for x. Okay? So look at this here. This is my bx plus c. if I want to figure out the phase shift, right, all I do is take the 5x plus 4 and set it equal to 0. When I do that, what do I get for x? Okay, so here I want to find the phase shift, meaning I'm going to take 5x plus pi over 4 and set it equal to 0. So 5x is negative pi over 4, x is negative pi over 20. So the phase shift is negative pi over 20, meaning this thing has moved to the left pi over 20. Well, if you divide by 5, it's like doing 1 over 5, 1 over 5. So it's pi over 20. Okay? All right. So what's the amplitude of this wave? Amplitude, amplitude, amplitude. 2. Huh? No, remember when it's like, when you move something like x plus 3 squared, right? The plus means it moves that way. Right. Because it moves negative 3. It moves to negative 3. You know what I mean? Like to negative 5 pi over 4. Okay. So the period, you take this number for the period. It's 2 pi over b, which is 2 pi over 5. So that's your period. How do you go from period to frequency? Flip it over. Huh? Yes, pi is a normal, cute little number. All right, so to graph this, here's what we're going to do. We're going to go 0 less than or equal to 5x plus pi over 4 less than or equal to 2 pi. And it looks like I need to stop here. So let me tell you what your homework will be. We have the right page this time. 264. And by the way, I'm collecting, what am I collecting? Section 1 and 2, so give me those before you leave. And you're just going to do the first 3 here. Okay, 3, 7, and 11 due Monday. All right? Huh?